these are not finding the integral, it's just finding the letters A, B, and C. So having it written like this, notice there's no integral sign. I'm going to multiply both sides by this denominator, so that on this side it'll cancel. And then I'm going to have to be careful over here. This is where most of the mistakes are made. X minus 2 squared. So these cancel, so I'm left with x squared plus 1. And on the right-hand side, let's be careful as we go. So this term times those gives me a times x minus 2 squared. Plus, if I take this term times these, one of the x minus 2's goes away, but I'm still left with one of them. And then if I multiply this term times this, I get plus a c. Both of the x minus 2 terms goes away, so I'm left with this. So always start off with the wise number, so I can see that x equal 2 is a wise number. So let's plug that in. So if I plug in x equal 2, I get 5. That's 0, that's 0. So 2 minus 3 is a negative 1. So C is negative 5. Got it. Now let's go find another wise number, and that would be x equals 3, because x equals 3 makes both of those 0. So here I would get 10 equal, and then put in x equals 3 into here. So 3 minus 2 is 1, so A is 10. All right, now we're at a kind of a roadblock, so we want to find what that B is equal to. So I'm noticing that this term B is in front of an x squared term. So if I was to compare x squared terms, on the right-hand side, I can see I have a bx squared. There's no x squared terms in here. And here, I'd also have an ax squared. And on the left-hand side, I have 1x squared. So that gives me 1 is equal to a plus b. I know that a is 10. So b must be negative 9. And that's all you needed to do for this part. We'll keep going on the next, how to integrate that next. But for right now, that's all we needed. Okay, let's do the same thing here. We're going to multiply both sides by the denominator. X minus 1. Let me make room. And x squared plus 4. Okay, lots of parentheses here. This denominator goes away. Equal. So then the x minus 1's cancel when I multiply this term times this. So I get a times x squared plus 4. Then, when I multiply this term times this, the x squared plus 4 go away. So you get bx plus c all times x minus 1. Be careful about the parentheses here. Really, really important. There is one good number to plug in, and that's 1. Right? Because there's no numbers you can put in here. So when I plug in 1, I get 1 minus 1, so I get a negative 2 over here. And I plug in 1, and I get a times 5, so negative 2/5 is a. All right, so let's think about what can we do. Let's do that x squared thing again. So x squared terms. X squared terms. On the left-hand side, I have a 1x squared. On the right-hand side, I have ax squared plus bx squared. So 1 is equal to a plus b. A was negative 2/5. So if I add that over to the other side, I'll get 7/5 is equal to my b. Okay, so then what? Now I need to go find the c. So where is c? Right there. So let's be careful with this. We could either use the constant terms or the x terms, but I don't know. This one's, I've seen so many people make mistakes. Let's just multiply it out so we can see exactly what the terms are. So this gives me bx squared minus bx plus cx minus a c. Whoops, minus a c. Okay, so if I was to compare x terms, I would say, okay, on the right-hand side, I'd have a minus bx, a plus cx. There's no x terms in here. And over here, I get a negative 2x. So that tells me negative 2 is equal to negative b. Oh, but I know b, negative 7/5 plus c. And so then I could figure out that c was 3/5. I'm sorry, negative 3/5. And that would be it. You could also, if you wanted to, use the constant terms. So the constant terms would be from this right-hand side, I'd get negative c. From this term here, I'd have a 4a, so 4a minus c. And on the left-hand side, that's negative 1. You would still get the same answer for c.